Call this Younger Dryas Explosion video number 4. Let's use Al Gore's temperature chart that he made famous back around 1990 or 2000. And I have a representation of it. 0 is today's temperature, 2 degrees hotter than today, 2 degrees colder than today. And you see that the temperature has gone up and down. Here is the Little Ice Age, so-called. Here is the so-called medieval warm period. And here is the Roman warm period, about 2,000 years ago. And you see it's gone up and down over the past several thousand years. Here's 4,000 years ago. Now let's zoom out and get an overview of a bigger picture. Here's the same representation, about a 15,000, 12,000 year period, because here is the Younger Dryas, a dip, an unusual dip, going down to the glacial maximum. 20,000 years ago, the Earth was covered with, quite a bit of land was covered with glaciers, ice sheets, a couple miles thick. And then about 12,000 years ago, it warmed up, but then suddenly went down again into a cold snap called the Younger Dryas. All right, now we're back in time. We're back to the period of time, the Younger Dryas, about roughly 14,000 years ago, 13,000 years ago. And we're looking down on the North Pole from space. And here is a big rock approaching the Earth, and it's traveling pretty fast, like say 20,000 miles per second. And in about a second's time, it passed through the atmosphere. Here is a cross-section view of the ice sheet above, on top of Canada, the crust of the Earth. Let's just say it passed through 10 miles of atmosphere and approached the ice, which is 2 miles thick, or maybe 3 miles thick. Here's the Earth's crust, perhaps 20 miles thick. And this is a cartoon representation of what happened. 1, 2, 3. This is the ice. I propose that it began to immediately penetrate the ice, and the ice moved out of the way, allowing it to go very deep into the ice. It could possibly, in a second's time, have penetrated a mile into the ice, and the ice squished out of the way. And this thing is red hot, superheated, moving very fast. Number 6. Here is a representation of this thing traveling deep into the ice. The ice is squishing out of the way. Ice extrudes, allowing this super hot, super fast rock to penetrate instantly, a mile deep, where it begins to break the ice, and the hot water vapor begins to expand, and the ice begins to break apart. And here's the illustration showing the ice breaking apart underground as the explosion of superheated water vapor violently tears the ice up out of the ground. And here's a view from space looking down on a huge hole in the ice around Canadian border, and chunks of ice being thrown up through the Earth's atmosphere into space. That's the point that I want to make to complement Antonio Zamora's work on the Younger Dryas impact. I want to emphasize that it likely penetrated deep into the ice, at which point a huge explosion occurred of superheated, extremely hot water vapor, which busted the ice up and threw it into the sky above the Earth's atmosphere, where it easily traveled in space for hundreds of miles before re-entering the Earth's atmosphere and sending greatly ablated chunks of ice to land along the Atlantic coast, and we know it landed on the Atlantic coast, but it also landed and left evidence in Nebraska. The Nebraska rainwater basins are the remnants of these huge chunks of ice that impacted across the landscape. That would have been a tremendous hailstorm on North America, but also would have put tremendous water vapor, which turned to ice crystals, in low Earth orbit, as Antonio has said, so that the Northern Hemisphere was shielded from sunlight for years and years and years, and a lot of plants died, so therefore a lot of herbivores died. And of course, the large herbivores died first, and followed by the large carnivores, because they depended on those large grass-eating animals like mastodons and woolly mammoths for food. But closer to the equator, smaller animals survived, and a few people, human beings, survived, and basically replenished the earth afterwards in the succeeding 10,000 years. There we go. Thanks for watching.